Hi everyone. So today I'll be taking you through the computer vision. In specific, we'll be focusing on custom vision as well as the face service on Azure. This is a follow-up session from the Game of Learners clinics that we had on Tuesday. So this is just a follow-up to do the demos as well as an in-depth explanation of everything. And probably just an update for anyone who's new watching this video for the first time and not part of the program. I'm Bethany Jepchumba. I'm a cloud advocate at Microsoft, and this is our 5th session of the program. Okay, let's go ahead and continue the slides. As I mentioned, the focus of today will be custom vision and the face service, and you can find the links to the resources and to the Learn modules at aka.ms/GOL/AIML-CV. Our learning objectives for today are first to classify images with a custom vision service. So we'll dig a bit into how classification works and then go ahead and do a demo with the custom vision service. And then the second part will be to detect and analyze faces with a face service. So same thing, we'll do a deep dive into what the face service is, what it can do, and then a demo at the end. An introduction, probably if you're new to computer vision. So computer vision is a part of the machine learning and technically deep learning, whereby using things like neural networks and convolution neural networks, you're able to read images in terms of pixels and understand what the image is all about, and then predict, probably by passing through various images, you can be able to predict whether a face is contained in a certain image or whether an image predicts one category or the other. In image classification, we use the same thing. We harness the power of machine learning to enable AI systems or applications to identify items based on the images that have been supplied. Classification is a technique whereby you're predicting the category or a class where an item belongs to. So let's say you're classifying fruits. So you have to classify whether the fruit is a banana, an apple, or an orange. And in classification, we use things called inputs. So inputs, we normally call them features, and these inputs are like different images that you use to train the model, and then it calculates now, like once your model is trained, you can be able to calculate the probability score of each image that you upload, and then it indicates the label, or in our case, the category that the object most likely belongs to. This is an example of how image classification looks like. So you can see it's like a banana, an image of a banana, and then it has like pixels values around the whole image, and you can be able to tell whether, yes, this is a banana, an apple, or an orange. So that's entirety it, the entirety of image classification, just being able to classify where an image belongs to. In Azure Custom Vision, we understand the intensity and the capacity that it will take for you to train a model. Therefore, using Custom Vision, you can quickly train your model without writing any line of code. So the first thing is you must first use existing images to train the model, and then once you've trained your model, you upload images, tag them, saying, hey, this is a fruit, this is a banana, this is an apple, and then train your model. Once your training is done, you can publish the model so that client applications can be able to use it to generate predictions. And model training and application, I've already outlined that you must first upload images and add tags to the images to appropriate the classes they belong to. And then once your image is uploaded, there are things that you can use to test whether the training model was useful or not. And we do it using the following metrics. The first one is precision. So precision is the percentage of class predictions that are correct. So it's all about accuracy. How many predictions that are correct were actually correct. And then recall is about the percentage of class predictions the model correctly identified. So let's say under something like the fruits, and you had 10 apples, and it was only able to classify 7 apples out of the 10. So that means the percentage will be 70. But then with precision, it's just the overall accuracy. So it predicted there are like 12 apples and you only had 10 apples. So the percentage will be 10 over 12, and so on and so forth. And then the last prediction metric that we use is the average precision, which considers both precision and recall. We'll now dive into the application, how we can be able to actually implement what you've been doing in custom vision. So on the screen, you can see the link to the dataset that we'll be using, aka.ms/gl-derivative. So we're going to do something very simple, which is determining whether someone's eyes have diabetes retinopathy or not. So diabetes retinopathy is a condition that causes blindness, caused of course by diabetes, and it's a serious issue, especially in the developing countries. So using custom vision, you can actually be able to tell whether someone eyes are going to indicate the presence of diabetes retinopathy or not, and be able to find a cure before then. So the first thing we'll do is identify the resource that we want to create. And for our case, the resource is custom vision. If you can see the custom vision resource on your screen, you can either do a quick search here or go and create a resource. Under categories, AI and machine learning, there is, interestingly, no custom vision here. So that means you'll have to go ahead and search custom vision. And let's see. Yep, so this is the custom vision service that we'll be using. As you can see, it's an end-to-end platform for applying computer vision to a specific scenario. So we'll go ahead and create a custom vision service. As we create the service, the first thing is the create options, whereby what we want to do is both prediction and training. So we'll go with both. And then our subscription, the subscription that you have, which is Azure for Students. If you don't have Azure for Students like me, you can use any of the subscriptions that you have. I'll use my Visual Studio subscription. No, I'll go back and use my MSDN subscription. And then resource group, you can create a new resource group for this, so that at the end you can be able to delete the resources. Or if you're like me and you already have like demo AI resource group, you can go ahead and add it there. Then select a region based on now the location that you are closest to reduce latency, as well as other factors, probably the availability of resources. Then from there, identify the name of your resource. So it will be diabetes retinopathy. And then pricing tier. Oh, I already have this. So I'll go diabetes retinopathy demo. Yep, it's available. You can add your name at the end so that to make it unique. So for me, instead of demo, I could have added Bethany. And then the training pricing tier, I'll suggest you go with free. Then also the prediction with free, because it's easier, it's a bit cheaper. But then at the end, we'll also have to delete all the resources to to be able to ensure our credits do not deplete. So I'll go ahead and review and create. You might have like a checkbox for responsible AI at the end on that screen. So probably that's something also you need to check. Once the resource is created, once the resource is creating, we'll go ahead to the custom vision site. So the site is customvision.ai. Yeah, our deployment is in progress. So in customvision.ai, you just sign in with the email that you use for your Azure portal. So it will just load in into your account. We'll give it a second. Let's see if our deployment is complete. Not yet. So as you can see, I already have previous projects done, but we can go ahead and create a new project for this. Let me see. Yeah, deployment is complete. You can go to the resource group. You can see the subscription ID. You can also see things like your deployment keys. So this is the 13 deployments succeeded. So what are we looking for? Our prediction. This is our prediction, diabetes retinopathy demo prediction. And then we're supposed to have our training. I'm not sure where it is, but this is our prediction key. So in case you need like your keys and endpoints, you can be able to find them all here. Yeah, your keys and your endpoints can be able to be found here. So mine are blurred, as you can see, so that you're not able to see the keys and endpoints that I use. But then we're done with that, so we'll go ahead and create our project. So diabetes retinopathy project description. We're trying to detect diabetic retinopathy from image classification. Our platform that we're using, it's the resource that we're using, diabetes retinopathy demo. We're doing it classification. Classification type is multi-class, meaning only one tag per image. So the image either has diabetes retinopathy or does not. And then general, the domain is just a general domain. We'll go ahead and create our project. And then to access our dataset, as I said, it is at aka.ms/gol hyphen diabetes reti, so di and then you'll be able to access all these images, so you can download them. It's a huge dataset, so it might take a while to download and everything, but once downloaded, you can go ahead and add your images. So I'll go to downloads, archive 100 images, and the normal I'll download first the normal. There are a couple of images already here, so I'll just upload all of them. These ones are normal, so they're negative, they do not contain diabetes retinopathy. I'll wait for it to download, to upload, and then I also get the second set of images. So let's give it a second. So it takes a bit of time to upload. So that's the first one uploaded. And then I also need to add images that show diabetes retinopathy. So it will be this DR images. So we go with DR1 and also upload all of them. Open, and then this will show positive as they contain the diabetes retinopathy. So I'll also upload this, and it will of course also take a bit of time. Once the uploading is done, we'll go ahead and train our images. So probably as we wait for it to download, let me be opening a previous example so that we can be able to test it while the other one is training. So this is a project I had done before. Okay, our images have uploaded successfully. We've been able to label the tags, so you can see like this image has the tag positive and so on. So you already have 37 negative, 16 positive. That's enough images. So we'll go ahead and train our image. So we're just doing a quick train because of the time that we have for this session. So it will go ahead and train. It will take about 2 to 5 minutes to finish training. So as we wait for it, maybe we'll come to an already trained data set, and then check on things like the performance. So you can see it's telling us the prediction is at 100, recall is at 100, the average precision is also at 100. This might be inaccurate or accurate based on the training, but now the main issue is the imbalance in the training and in the training data sets. So it might have caused all of them to be 100, or our prediction might be very perfect. But then that's it. Once your training is complete, you'll come to this page. It will give you an idea of how the model has performed, and you can go ahead and publish. So you'll click publish, and you'll be able to publish your model, and you can be able to use it. So one thing we can test is probably testing whether the prediction made is correct or wrong. So we can just do a quick Google search and search for diabetes di- diabetes retinopathy. And then of course it will give us images that show diabetes retinopathy on the eye. We'll copy the image link and test to see if it is okay or not. So let's check and see. This one has diabetes retinopathy, and it's telling us the probability is it is positive is about 77.9%. That means our project is actually successful. So because the percentage of it's an eye that has diabetes retinopathy. Let's see if our previous yeah. The previous one is yet to complete training. So I'll continue with this since it's accurate, and we'll go ahead and try and test to see how it will perform. So we'll go ahead and take the prediction API. So we want to predict whether an image has diabetes retinopathy or not using an API. In our case, I'll use Postman to check this. And with Postman, our authorization is an API key. So we add the value of our API key here. I'll go back to our portal and copy the API key, come back here and paste the API key. That's the value we're using. And then under headers, as it is mentioned here, we have to set the prediction key to this. So we will be using a URL to test the image. So prediction key will be that, and then the content type is of course JSON, as it has been stated here, content type application JSON, and then body, we can copy the image link and add to the body. So copy image link, come to the body is raw and a raw JSON, and then an image, a link to an image, the one we just tested right now. I am not sure if it will be able to predict this as an image, but let's see. And then the other thing is this is a post prediction. So we'll copy link on our the link and do a post. So Control A, Control V, then send the request and see if it will give us an answer. So access denied, invalid subscription key, or wrong API. So the problem is with our API key. So let me see if I update this. Let's see if it will give us a prediction. Yep. So yeah, it's giving us the same thing. So if you write code, this is what it will give you as the output. So it will tell you this is this iteration of training, the project term, the ID, and then the probability that this is positive is 0.7%, 0.7. Probability it's negative is 0.2. So with this, you can be able to tell, yes, the I is diabetes. So once you're setting your variable keys, this is what you'll continue to do. Okay, that's it about the Face API. So as you can see, the main issue here is the imbalance in the data set, but the data set is working okay and it can be able to predict whether it's positive or negative. So our model is done here. You can go ahead and publish, choose your model name. So you can name it diabetes retinopathy, and then the prediction key, the resource you're using is the prediction key, and then that's about it. Go ahead and test your predictions here. You can also do a quick train, an advanced training. So this is if you have time and you want your model to actually work very well, you give it more time. Okay, that's it about the custom vision. So let's head back to our slides and check on the next part, which is the face API. The face service. So face service is about face detection and analysis, and it's whereby you use algorithms to determine where exactly the face is located and analyze the image. So for example, I'll show you the next slide. You can analyze whether someone is wearing a mask or not and so on. It's useful in both images and video content, and it gives you an in-depth idea of what exactly is contained in a face. Unlike the cognitive service, which we'll learn in the next session, the Face API gives you an in-depth description of the facial description of someone. So, for example, the first thing it can do is it returns, like the first image here, it returns a bounding box where the faces are found. And then the second thing is it returns also information on like facial landmarks. So it tells you, hey, this is your right eyebrow, the lip, and so on. It can also identify like things found in a face. So, for example, indicating the blur, indicating whether someone has glasses, indicating the occlusion, which is if there's an image blocking the face. And then the last thing is detecting, identifying faces. So identifying, hey, this is Satya Nandala, hey, this is Bethany, hey, this is so and so. So you can be able to do this. And one of the main applications for face identity is security. For example, in CCTV cameras, if an armed robber comes into your house and steals things, and you can use the face API to determine who the face belongs to. And then the other thing is, of course, in social media, as you can see, for example, in Instagram or Facebook, it can give you an idea of like, hey, this so and so is in this picture. Maybe you can tag them, or in your history, you can be able to classify people in your OneDrive or so on. You can be able to classify people based on their images. And then the other thing is identity validation, which is very useful in security. Okay, so let's go to our exercise. But before we go to the exercise, maybe I'll mention two things. So one of the tips for accurate results is ensure your image format is in JPEG or PNG or GIF. Size about 6 MB or smaller, and then have it in a square ratio that is either 36 by 36 or an upwards of up to 4096 by 4096. And then another thing is ensuring there are no obstructions to the face, which will now give you an accurate description. Okay, so let's go to our exercise, which is the first thing we'll do is, of course, create the face API. So create a resource under AI and machine learning. We create the face. So go ahead and create face. And then do the same thing. Resource group, I'll use demo AI. Region, I'll use the syrup, name, face, detection, demo, pricing tier. Go ahead with the fruit pricing tier. Oh, the name is already used. Okay, so instead of demo, I'll use my name. Let's see if it's used. Yeah, that's better. Review and create. So after that, you just go and review and create. So once you've been able to create your resource, you want to do, let me duplicate this tab so that I show you what we'll do next. Once the validation is passed, go ahead and create your service. And then we also want to now test this in terms of, we also want to test this in form of something like a repo that we can be able to use. So we'll use Cloud Shell. And if you do not already have storage, it will prompt you to create your storage. But if you do, it's something that you can go ahead. But then for me, since I don't have my storage, I'll go ahead and create a storage so that to be able to run it on to be able to run the Cloud Shell, it requires a storage. Let's see if our deployment, yeah, our deployment is complete. You can see the resource is done. The keys and endpoints are good. Okay, so we're waiting for our storage to complete. Let's give it a few seconds. But then the main thing also here is the keys and your endpoint that you'll use. If you need to do more with the Face API, you can look at the quick start guides. So if you, like me, code in Python, you can just look at the Python quick start code and continue with it. Also, there's a lot of documentation available for you to explore. Okay, so our Cloud Shell is up and we'll be using PowerShell, so we'll just retain it as PowerShell. And the first thing we'll do is clone the GitHub repo that we might need. And once the repo is cloned, we'll go ahead and look at the code. So the repo is under the Microsoft Learning, then under AI Fundamentals, AI 900. And once you clone the repo, we want to specifically focus on the code under Face API. So we'll open the code, and then under AI 900, we'll go ahead to find faces. And And then under find faces, the main thing you need to do is replace your key and endpoint here. So our keys, our key, let's replace it there. And then our endpoint, let's also replace it there. So about the code, it's just basically the first thing is you uploading your key and endpoint, and then you selecting the image. So all this is about determining which image is there. So the image file, of course, the first file is the store camera one, but if in the argument counts, you can be able to define which image you want, and then this is now you defining the image. The other thing is the headers. So the headers are where you put your keys and then the content type, which is of course application JSON. The body is now you adding the URL of your image. And then this is you now calling the image to analyze a face. So once you've done that, the thing is you just go ahead and run your code. So at the top right of the editor, you can open the menu. So I'm not sure where my menu is at. So I've just used Control S to save. And then once you save, you can also be able to you can be able to run the code. So we'll go directly into AI 900. And then under AI 900, we want to run the file find faces.psi1. Let's see. And it's given us the output. This code is restricted to returning the location of any faces detected. So the location is, that is the location of the face returned. So unfortunately, we cannot be able to detect the individual identifying faces of the individual, but you can be able to see like the location of where the face is at. And if you look at the image that is supporting this, you will be able to find that that's the exact location where the image is. And you can go ahead and try different images. As you can see, you can try out different images and check to see if, of course, they have returned the right location of the image and so on. But then this is a restriction that you cannot be able to return personally identifiable features because of responsible AI. But I think you've been able to get a gist of what you can be able to do with the face service. That's it from my end. We've covered an exercise, and then the last thing I'll want you to do is go back to Azure portal, go back to your Azure portal and delete the resources. Once you're done using it, go back, check all your resources, and one by one ensure you've been able to delete them, including like the repository that the resource group that you just created. So you can delete both the resource group as well as the storage account. That's it from my end. Thank you so much for taking your time and listening in. I hope the session was informative. Have a great rest of your day.